Alright, welcome to the second video in the series of AP Physics 1 Math Review. This video will dive into dimensional analysis. So let's go right into it. Alright, so units you will deal with throughout this year. So at the very top here we have our standard English units. These are kind of the ones we deal with in everyday life here in the US. But they're not the units you're going to deal with in a science class for the most part. So you have there that length is measured in feet. Whenever you use a meter stick, do not use the inches side. I will go over this probably many times throughout the year, but just make sure that we are working with our metric units or our SI units, not the English units. Mass is actually measured in a unit called slugs, not pounds. I'm going to go over the mass versus weight idea at one point during the year, and you get my little rant on that. But right now it's not the time for it. We don't really need to have that idea in our heads at the moment. And time is measured in seconds. This is the one unit that actually carries between both the English units and the SI units. So it's always going to be used. You always want to get into seconds besides some special situations, but it doesn't really come up that often. If it ever came up, it would come up for Regents, not AP, but it doesn't really come up at all there either. So you don't worry about that at all. The other one here are SI units. These are the units we're going to use throughout the class. If you've heard this before in a science class, SI is the International System of Units. It is used by pretty much every country besides the United States. Length is measured in meters. If you're a track runner, you have a good idea of what a meter is. If you run, say, the 400 or the 800, you should have a good or a much better idea than the average person in this country of what meters are to feet and things like that. Mass is measured using the kilogram. If you want an easy conversion of that into pounds, for our purposes, around 2.2 pounds is 1 kilogram. And time again is measured in seconds. SI units, like I said, these are the main standards of measurement in this class. The units are very important in Regents questions to show work for that. It's not as important in the AP questions, but we'll still use them to kind of figure out what type of physical quantity we do have. Other important units for later that will be used on the graphing portion of the summary assignment. Your velocity / speed is in meters per second, and we'll talk about the distinction between those over the course of the class. And then acceleration is in meters per second squared, or meters per second per second. Again, we don't need to know what these things mean at the moment. They'll just be used later on in the summary assignment. All right, so let's move into how we actually convert units. All right, so we have here how to actually convert from one unit to another. At the very bottom of the page, I have there all the prefixes. On each of the slides, I'm going to have the prefix chart from the AP Physics 1 reference table. Again, this is something that doesn't really come up all the time in AP 1, but it will come up in Regents over the course of the year, and we'll do it a lot in labs and things like that. So that's why it is important to know how to convert, especially going from centimeters into meters and going from grams into kilograms. Otherwise, as far as like questions go, especially on AP Physics 1, you're not going to convert for a multiple choice question. It's not going to come up. It might be something that comes up in a multiple choice question on the Regents. It did come up at least once or twice on last year's Regents exam, or this year's Regents exam actually. So what we have here is called the factor label method. So this requires you to multiply your given by a series of factors in order for the units you do not want to cancel out and the units you do want to remain. So for example, we're going to convert here 10 kilometers per hour to meters per second, and I have it written out there already. First, we can either identify the conversion factors, which we must for our time, because we don't have an easy like prefix way to go about that. We can also kind of like memorize that 1 kilometer is 1,000 meters, but I don't necessarily recommend that if you can use the prefix chart. So then we're going to set up the series of factors with the appropriate units canceling out. So you start out here at the very beginning with 10 kilometers over 1 hour. We can see based on the prefix chart, and it shows this really well with all the meters, that meter has no prefix. So you're either going up or you're going down on the prefix chart with this. What we're going to do here is we want to cancel out kilometers. So if you look here on the chart, or on my little work sample here, I have 10 kilometers over 1 hour. On the bottom in the next set of numbers, I set up kilometers there on the bottom, so I end up canceling out my kilometers here. I can also see that based on the prefix chart, that 1 kilometer is going to be 1 times 10 to the third meters, or in just regular terms, 1,000 meters. That's how I'm usually going to set up, and I'll go through that as well. That's basically all that prefix chart is telling you. It's saying for 1 kilometer, that is 1 times 10 to the third meters. So say if you had it in grams instead, and you wanted to go into kilograms, 1 kilogram is 1 times 10 to the third grams. So same idea. So now we are into meters because we have canceled out our kilometers. Now looking at the time here, we have hours on the bottom, we have hours on top, so those are going to end up canceling out. I know that for 1 hour I have 60 minutes, so that goes on the bottom. And I'm going to have to then further cancel out minutes because I want it to be in seconds. So you see the next step in the math here is doing 1 minute over 60 seconds. Again, you want to cancel out the minutes here. So those will cancel, and I should be left with the units of meters over seconds. So all you have to do now is just do the math straight across. So 10 times 1,000. And then 60 times 60 on the bottom because all the rest of it is multiplied by 1. You end up there with 10,000 meters over 3,600 seconds. And then just further getting that down, you're going to have 2.8 meters per second. All right, so let's move into our examples. All right, so example number 1, we're just going to do a simple conversion, just going from one distance to another. We're not worried about like per second or anything like that for now. We have here 785.3 kilometers is equal to whatever meters. So again, setting up my conversion factor here, I'm going to have here that 785.3 kilometers. I'm then going to set up my conversion here. So if I look on my prefix table, I can see that kilo is times 10 to the third. So what I'm going to do is set up what 1 kilometer is. So I have 1 kilometer on the bottom because again, I want to cancel out that unit. On top, I want meters. That's the unit that I want at the end of the day. And I can see here based on the table, kilometer or kilo is 10 to the third. So that's going to be 1 times 10 to the third meters. So that's all I have to do for this conversion because I'm going straight from kilometers into meters. My kilometers will cancel out, and I'm just going to have 785.3 essentially times 1,000. So you can just plug this into your calculator real quick. And you should end up with an answer here of 785,300. And you can further put this into scientific notation. So a little bit further practice on that. If you look at the numerals before where my decimal would be, you have 1, 2, 3, 4, 5, 6. So I could end up here with 7.85 times 10 to the fifth because I have 6 numerals before the decimal. So 7.85 times 10 to the fifth meters would also be an acceptable answer. So let's move in to my next example. All right, moving into our second example. This is a conversion that often happens in this class. 500 grams into kilograms. So we have here again, just write out everything. So I have 500 grams multiplied by, I can put on top here 1 kilogram. And then I want my grams on the bottom. So what does it tell me that 1 kilogram is in grams based on the table? It says that is going to be 10 to the third. So I can put here on the bottom 1 times 10 to the third grams. And again, you want grams on the bottom because you're canceling out that unit and you're going to end up with your new unit as kilograms. So all I'm going to do here is just cancel this out. So my grams should cancel. I should just end up with essentially 500 over 1 times 10 to the third, which again is just 1,000. So I should now end up with my new value here in kilograms. So 500 divided by 1,000 should give me 0.5. So I'm going to have 0.5 kg. And this is a nice enough number that I'm not going to put it into scientific notation. So I'm just going to leave this as is. So let's move into my next example. All right, moving into example 3, we're going to convert 5 centimeters per minute into meters per second. So again, this one's a little bit more difficult than the previous two because now we're dealing with 2 different types of units instead of just one. So let's just start by setting it up. So I have here 5 centimeters per 1 minute. And then we're going to multiply that. So what I'm going to do here, I want this in meters. So I'll put here again centimeters on the bottom because I want to cancel out centimeters, and I'm going to look on the table to see how many meters is 1 centimeter. So again, looking at the prefixes, you have centi, that's 10 to the negative second. So 1 times 10 to the negative second meters is 1 centimeter. So we should now have centimeters canceled out. Now we want to go from minutes into seconds. So I put on the top here 1 minute. And I know that the amount of seconds in 1 minute is going to be 60 seconds. So we'll just put here 60s. And now we should have our conversion done. So we've canceled out minutes and we've canceled out centimeters. So we should be left with our units as meters per second. So now let's just do the math straight across. So 5 times 1 times 10 to the second, 10 to the negative second. So 10 to the negative second times 5. That on top is going to be 0.5. So 0.05, and that's going to be in meters over 60 seconds for the moment. Just divide those to get the final answer. So 0.05 divided by 60 is going to give me 8.3 times 10 to the negative fourth meters per second. Again, your calculator should give you that straight away in scientific notation because it is a small enough number. So let's move into our final example. All right, so our last example is similar to the one I did on the first page there when I explained conversions. We have here 300 kilometers an hour into meters per second. This is a pretty fast speed. If anybody watches Formula 1, this should be like a number that you've seen before as far as like on a high speed track like Monza. So if you don't have an idea with this, just kind of look up what 300 kilometers an hour is in miles per hour, and it's pretty fast. So we have here 300 kilometers per hour. So let's set up against the 300 kilometers per 1 hour. So we have a little bit more converting to do here than in the previous one for our time, but the kilometers we've actually done before on a previous question. So again, let's set this up. I'll start off with kilometers first into meters because that's the one that's on top. So I'm going to put there on the bottom 1 kilometer. And look for what 1 kilometer is in meters on my table. I can see that a kilo is 10 to the third, so that's going to be 1 times 10 to the third meters. So our kilometers is now canceled out, and we're in the proper units for distance. So going from hours into seconds, I can do a straight away conversion, but I'm just going to do it in 2 steps. So I want to go into minutes first and then go into seconds. So we're going to put it on top here again, hours, so 1 hour. We know that in 1 hour we have 60 minutes. So now we can cancel out our hours and we'll be in meters per minute, but we want in meters per second. So let's do our final conversion. So 1 minute on top, since again we want to cancel out that unit. On the bottom we are going to put seconds. We know that there is 60 seconds in 1 minute. Alright, so now we should have everything properly canceled out and we should have the proper units. I have here on top just meters left, and I have there on the bottom just seconds left. So now doing the answer here, plugging everything into your calculator. So essentially 300 times 1,000 is going to be 300,000. Then that is going to be over, so that's going to be in meters. That is going to be over just 60 times 60. So if you plug in that into your calculator, you should get 3,600 seconds. So let's do the quick division here and get this in just meters per 1 second. So 300,000 over 3,600. And you should end up with an answer of 83.3. Just leave it at 83.3. 83.3 meters per second should be your final answer. Alright, so I hope this walkthrough of unit conversion or dimensional analysis was helpful. Good luck with the rest of the summer assignment, and I will continue to post videos for this math series.